We're ready to start section 3 out of chapter 2, and we are going to start with basic differentiation formulas. So we only have one note in this section. It's actually going to go by pretty quick here. We are going to set up, or I'm going to give you some formulas now, and these are called shortcut formulas, and they will allow us to compute the derivative without having to use the limit definition. So we saw before that to figure out what the derivative of a function was, we had to take a limit, and there were two different formulas that we could use. Now our life will become drastically easier because we will have these shortcut rules, but that will mean later on we'll be taking the derivatives of some much more complicated functions. So here are the basic differentiation formulas. First one, the derivative with respect to x of any constant is equal to 0. So the derivative of a constant is 0. Think about it this way. If you have a constant function that's just a flat line, then the slope of the tangent line is also flat. So it should have a slope of 0. So that's what we're saying here. The second formula says that the derivative with respect to x of x itself is 1. And the way you can figure this out is, remember what x, the function f of x equals x is. That's the diagonal line, or the identity function, and the slope of that line is 1. So that's all we're saying here, is that the slope of the identity function is always 1. Now the next rule is one of the most important rules for the basic differentiation formulas. It's called the power rule. It says that if you're trying to take the derivative with respect to x of x raised to some power n, that the derivative is, without having to compute a limit or anything, the derivative will be n times x raised to the n minus 1. So a way to kind of remember this rule is, what's happening is that if you have x raised to a power, when you take the derivative, the power drops out in front, so that's the n in front, and then you always subtract 1 from whatever the power was. So we'll see some examples we'll do in class, but just remember the power comes out and then subtract 1 from the power. That's your new power. The next rule talks about what happens if you take the derivative of a function times a constant. So if you have a constant sitting in front of some function, how does that constant affect the answer? Well, it turns out that all you have to do is take the constant and pull it out in front and then take the derivative of the function. So constants can come out and then take the derivative. Do not confuse this with rule 1, which said the derivative of a constant is 0. The reason why this is different than this is because the derivative of a constant by itself is 0. But the derivative of a constant attached to the function, or to a function, is whatever the constant is times the derivative of the function. So don't confuse those two. The next one is the sum difference rule. It says if you're taking the derivative of two functions being added together, then the answer is the derivative of the first function plus the derivative of the second function. Or if you're using subtraction, then it would be the difference or subtraction of the two derivatives. All this says is that the derivative of sums and products can be split up into derivatives of each one individually. So you don't have to add the functions and then take the derivative. You can take the derivative of each function and then add or subtract. Okay, these next couple of derivative rules are actually going to come later in the book, but I went ahead and included them now. The derivative of the sine function is the cosine function. The derivative of the cosine function is negative sine. The derivative of the cosine function is negative sine. So derivative of cosine x is negative sine x. The derivative of tangent to x is secant squared x. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of secant x is secant x tangent x. And the derivative of cotangent x is negative cosecant squared x. I'm going to prove all of these to you later on. We're just not quite ready for it right now. Mostly in this section, we're going to be working with these first 7 rules, and then later on we'll get to the rest, 8, 9, 10, and 11.